Okay, welcome to lesson 88 of algebraic concepts. Graph a situation. Here's our objective and our first example. A person walks down a hill, then up. Which graph represents the situation? Well, let's think about it. If a person walks downhill, they will be going fast, and if they walk uphill, they will be going slow. So in a speed versus time graph, a speed versus time graph is acceleration. And I guess this one will be the best one. Let me put my pen on so this doesn't move around. So from here to here, this should be a distance versus time graph. This would be better. This is positive acceleration. From here to here is constant speed. This part right here at 0 means it stopped for some time. So you accelerate it here, you decelerate it, and then you accelerate it again, and that doesn't match the situation. Graph 3, you accelerate it to some point, and then you decelerate it, negative acceleration, and let's see how far you went. Graph 3 means you constantly slowed down until you got to a certain number. All it says is a person walked downhill and then up. And I will assume that you went uphill at the same speed and it was slower than the accelerating rate of graph 1. So I think graph 1 represents the best situation. And graph 3 would means that you slowed down the higher you got up the hill, which is probably likely, but it does not say that in the situation. Okay, so let's talk about how to analyze this graph. So what do you have going on? So you have a distance changing. So let's call this section 1. Let's call this one section 2. Let's call this one section 3. Let's call this one section 4, section 5, and then section 6. So we have 6 sections that are going on in a day's commute. So what is going on? An object in section 1 is changing its distance for half an hour. So it has some speed. In section 2, it did not change its distance, so it is still. In section 3, it changed its distance over time, so it has some speed in section 3. In section 4, it came to a stop again. It did not have any speed from 2.5 to about 8 for about 6.5 hours. No change in speed. In section 5, it is coming back to where it started. So section 5 represents a return at a high rate of speed, and section 6 represent a rate of return at a low rate of speed. So what happens? The distance goes away in section 1. It stops in section 2. It goes further away at a faster rate than in section 1 and section 3. In section 4, the object stops again. In section 5, the object is coming back to where it started at a fast rate. And in section 6, is coming back to where it started at a slower rate. So that's how you read a graph, and that's what the information is telling you. So those were our 2 examples. Try to practice problems, and I will see you at the end of the video for a review. Okay, a race car on the racetrack speeds to maximum speed on the straight and then slows down on the curve. Which graph best represents the situation? So let's see what we have. Speed versus distance. So on a speed versus distance graph, this is speed, this is acceleration, this is deceleration, and this is constant speed. So the racetrack speeds to a maximum speed on a straight and slows down on a curve. Which one represents this? So we got constant acceleration to a constant speed and then deceleration. So a race car speeds, so all we have is traveling at a speed, then it speeds up on a straight, then slows back down on a curve, and then it speeds up again. So I think this graph would best represent this situation better than graph 2. I think graph 1. Okay, write a situation from the graph. So you don't have here, so what I will give you this as distance. Because if I said it was speed, then you would have to analyze the acceleration of the object. So speed, distance versus time. What do we know about distance versus time? This is speed. So an object is leaving the start at a constant speed. Then it slows. No, I'm sorry, it does not slow. This is a distance versus time graph. It does not slow down. It returns back to where it was. So it starts to come back. Then it leaves again. And how does it leave? With some speed. And right here at the top, it is still. It is not moving. So you can write whatever story you want. You will say, somebody was walking to school and they thought they forgot something. They started to walk back home, but realized their key was in their bag. So after wasting a couple of minutes, 20 seconds, worrying about what they left in their car, in their book bag or whatever, they turned around at 70 seconds and started going back towards school at a faster rate than what they originally walked with. And by 100 seconds, they got to where they were going and remained still for 20 seconds. And that's how you would write a situation. You would put in better words than I put in for you, but I was just analyzing the graph that we were looking at. So that's the end of this video. I thank you for watching it. Please subscribe and hit the notification bell so that you can catch more videos. And I will see you in the next video. And please share with other people. Thank you.